Hi everybody, welcome to navigating the new government rebate with Discover Energy Systems. I'm here with Matt and James from Discover in Canada, although, well, I'm supposed to be here with them, but they're not here. Apparently they were in the city and they lost track of time, and they're on a tram as we speak from Collins Street down to Port Melbourne, so hopefully they're going to be here anytime soon. But for now, this Victron hat and this NOAC hat are going to have to do the job. I guess we'll kick off. I'll just see how many people are in and whether we need to wait for anybody else. Okay. Yeah, all right, we'll kick off. So this presentation is mainly about the suitability of Discover batteries for the government rebate. I'm not going to go into huge amounts of detail on the details of the government rebate itself. We will do another webinar about that in 2 or 3 weeks' time, going into all the details, but there's a fair bit to cover with that. But we will talk about that to a certain extent for those who don't know. So the new federal rebate requirements, the battery needs to be CEC listed, which means it has to be a lithium battery for a start. There's no non-lithium batteries on the CEC list that only has provision for lithium batteries. So no tubular plate gel or molten salt batteries or anything like that. The inverter needs to be CEC listed. And if it's going to be on-grid, the system needs to be VPP capable, meaning it can connect to the electricity grid or external entities, can communicate and respond to remote signals, and supports the protocols needed to respond to external signals. And obviously, that's only for on-grid. For off-grid, because you're not connected to the grid, you can't be part of a VPP. The further rebate parameters are that a system must not have previously received a discount under the rebate program. New or upgraded capacity must be at least 5 kilowatt hours. And the total capacity must not exceed 100 kilowatt hours. You only get a rebate up to 50 kilowatt hours. And if you're adding or replacing battery capacity, then it has to be that the existing capacity hasn't already received support, or the new system or added capacity meets the 5 to 100 kilowatt hour requirement. So put in plain English, you can't upgrade old systems as long as they haven't had the rebate previously. And my understanding of it is that the inverter needs to be CEC approved or needed to be on the CEC list when the batteries were first installed. So if you have like a Victron Quattro, for instance, that's not currently on the list, but it was on the list sort of about 3 years ago. And so if it was on the list when the system was installed, that would be okay. Definitely worth checking on that in more detail before you do one of those systems though. So if we look into what inverters actually meet these requirements, on the CEC list and VPP capable if it's going to be for on-grid. For off-grid, all of the inverters that we sell are on the CEC list. So Cellectronic, Victron, NOAC, and Solus hybrid inverter, those are all on the CEC list. So you could use all of them for off-grid. You probably wouldn't use a Solus, or maybe you would, but they're mainly a hybrid inverter. A NOAC is a hybrid inverter mainly made for on the grid, but actually increasing the number of people using them for off-grid. And obviously Cellectronic and Victron are well known for that. For off-grid, there's a bit of a question mark around Victron. So the rules say that it needs to be VPP capable. To begin with, people were saying VPP ready, but it just says VPP capable, which means it's capable of joining a VPP. What's not clear is whether there needs to be some sort of statement of conformity from the inverter manufacturer to say that they're VPP capable, or specifying an exact protocol. It doesn't say that they need to be able to do CSIP. Cellectronic have released a statement saying that they're compatible with VPP. NOARC is available for VPP through, what's it called? Marshall
Zeco.
Marshall Zeco, that's right. Thanks, David. Marshall Zeco allows you to be part of a VPP, which is just an external comms device, which you just buy once, and that gives you VPP capabilities, and it also gives you backstop capabilities. Solus is VPP capable as well, but there's nothing been released from Victron. But as those of you who are familiar with Victron, when you pair it with a servo, it has probably the best comms options out of all of these inverters. And all NOARC has, and I imagine Solus is probably the same, is it just has Modbus RTU from a DB9 connector on the bottom of it. And that is what's used by the Zeco Marshall device to control it and talk to the VPP. And Victron has Modbus inbuilt, as well as MQTT, Node-RED, a bunch of other protocols. So it is certainly VPP capable, but whether that meets the definition that would be required is an open question as far as I know at the moment. So at the moment, if you're doing on-grid, I'd probably steer away from Victron. It also begs the question, the category that Victron inverters are in on the CEC list, they fall under a very specific clause of AS4777, which is Appendix M. And that means that they can't export to the grid. So the way I see it, there's not much point being part of a VPP if you can't actually export. But, you know, the people who are making the rules might not care about that. Cellectronic are not allowed to export their battery power either, because they're both low frequency inverters, and those, they have announced that they're VPP capable. And as far as I know, there's no argument about that. So it's all a bit uncertain at the moment. But certainly for off-grid, the Victron 48, 3000 and 5000 are on the CEC list, so you can use those for off-grid. The larger models of multi-plus 2s, the 10s and the 15s and the 8s, those are not on the list yet, but we're told that they will be on the list very soon. They've been saying that for a while, so I wouldn't hold your breath, but hopefully soon means before the end of the year, might even be a few months. They've got somebody on the case apparently to try and push it through a bit quicker, but obviously the CEC is probably a bit inundated at the moment as well. So not sure what the timeline is for that. The Discover product range. So for those of you who don't know Discover, they make lithium batteries. They're a Canadian-based company, and I did want to have these guys here to sort of tell you about it themselves, and they will be here at some point, but they're not here yet. So they make a rack mount battery. We've got on the left-hand side here, the AES rack mount. It's a 5 kilowatt-hour rack mount battery, 19-inch format, same as all the other rack mount batteries that are on the market at the moment. They make this thing here called a Link 2, which is basically a clever little comms device, which makes them quite unique in that instead of the CAN bus protocol coming from the battery like it does on most of these batteries, it actually comes from this little Link 2 box. And instead of the inverters having to change their protocol to suit the battery, they actually have their own protocol for each individual inverter, which makes them much more flexible. And it also has a web portal attached to it as well called the Link Cloud, and I'll go through that a little bit later on as well. And it has some little relays built into it. I'll go through it in a bit more detail in a moment. We then have this new product here called the Helios. This is an IP65 rated 16 kilowatt hour battery. You can you don't need a cabinet for it. It can go outside or inside. It has CAN bus built in, so you don't need the link to device in order to use it in a closed loop scenario. But you can use the link to if you want to put it onto the internet and use Link Cloud, which we recommend for some systems. And then we have, last but not least, this new product from Discover, which is a high voltage 210 kilowatt hour battery for the C&I market. As far as the rack mount battery goes, there's a range of cabinets that we sell for that. We've got the slimline cabinet on the left-hand side here that fits 6 of these batteries and is IP54 rated. It has a built-in bus bar, and it has a slot for the link to device as well. It's a really great product. I don't really get much of a sense from it from this picture here, but it's a really nice looking product, and the form factor is great for fitting down the side of a house, and you could put just 2 batteries in and upgrade it later on if you wanted to, or 2 or 4 or however many you like. Because they're stacked vertically, its profile is really nice and thin, and it has this nice sort of sloping roof, so it's got a bit of sort of elegance in the design. You can use that for indoor or outdoor. We've got the quick stack rack. You've probably seen these with other brands. I know that PylonTech do something very similar, and that's just something you can use for stacking batteries indoors. You can have up to 6 in a rack. Or in a tower, I should say, and then you can have a combiner module at the top as well, which is sold separately. We sell through DPA an 8 battery cabinet, IP20, that's just for inside use. We have an outdoor rated twin cabinet that fits 2 batteries, that's IP65 rated, and we also have a quad tower that fits 4. This is quite similar to the PylonTech cabinet that takes 4 batteries as well. It comes pre-wired. It's a nice form factor, nice and thin again, like the slimline cabinet is. And yeah, that covers most bases we find. So onto the AS rack mount. For those of you who don't know, it's a 5 kilowatt hour battery, but you can have up to 180 kilowatt hours of storage in one network. It includes a 2-pole breaker, and as well as the regular on-off switch. It's a 48-volt nominal battery. It's a 16-cell battery. It looks like the guys from Discover have just arrived. Come in, guys. So I had the webinar's running as we speak.
I see. Well, I'll sit where I'm supposed to.
Yeah,
sit.
James, you can come sit over here. I haven't actually met James in the flesh before.
Hi.
Hi. We've got Matt over here.
Thank you. Thank you.
We've
Sorry
both
for
got
being late.
Lost in town. So I'll just let you know where we're up to. I've just done a quick introduction about the rebate, and then we've just gone on to starting to talk about the rack mount battery.
Beautiful.
Talk about the features of that. And so, as I said, it's a 5 kilowatt hour battery. Just adjust this touch. 48 volt nominal. It's a 16 cell battery rather than a 15 cell battery, which some other manufacturers make in the same form factor, which means your inverter is going to be a little bit more efficient. And I've actually got an example here of some BMSs. So this is another manufacturer's BMS, which is a good battery that I like, but you can see that the positive connection goes directly to the cells from the front of the battery, and then the negative is what gets controlled by the BMS. The negative comes in here, and it goes through all these surface-mounted components and comes out there into the cells. And so if anything happens to these surface-mount components, that's just the end of it. This BMS is cooked. And they do actually, part of their protections is that they do deliberately trip some of these surface-mounted fuses. And once that happens, you just have to replace the BMS. And I've replaced a few of these, and it's pretty time-consuming and annoying to do this.
What current do you think can flow through that safely?
Well, yeah, that's a good question, isn't it? Like,
These are where all the current has to flow through the FETs.
Yeah. So, you know, the current capability of a surface mount component, and we'll compare that to what we've got here. So this is the Discover BMS. And again, the positive goes directly to the cells, but the negative is going to come through here, through the 2-pole breaker, and then it goes through these 2 big BYD contactors, and then straight out there to the cell there. So none of the power goes through the BMS. The BMS is just controlling these 2 contactors here. And so the robustness of that compared to this is just in a different league, really.
I'll add to that. These are latching style contactors. So when we close them in, it's a double redundant system. We actually store energy on the board to be able to reopen them in the event of a fault. But when they close in and they're in their static position, there's really no current needed to maintain them in that position. So in either state, whether they're open or closed, we don't really have to run a bunch of current through to only to change their state. So our parasitic draw, whether the battery is in a closed and on position or open and off position, is incredibly low. Dare I say, much lower than that even of a FET-based BMS. And one of the reasons for using FET-based BMSs early on was they're cheap to manufacture, but also they had a relatively low parasitic draw when you had to use old style contactors that required energy to stay closed. With our new design, our Gen 4 BMS, it's an incredibly reliable design, but really low parasitic draw.
So is that kind of like, it's almost like these are switches,
Yep.
motorized switches,
Yep.
rather than relays that require energy to hold
That's
them in
right.
position.
Yeah.
Yeah.
And they're more reliable.
And I think you can see the quality of the components on here as well. They're just bigger and chunkier, you know, much just better quality, I think.
And we have our pre-charge circuit as well.
Oh yeah. Is that a what is that?
It's a resistor.
Oh, it looks like a choke. Yeah, so I like to show that to people. And the purpose of it being, you can see this is mounted on this panel, which is the front of the battery. See, there's the amphenol connectors there and the circuit breaker. So if you do need to swap a BMS out, then when you want to do it on site, you just take this panel off the front, and there's a few little ribbon connectors here, and obviously the power connectors, and it's pretty quick and easy to change it out. And it's something that Discover allows service technicians to do, whereas this, you have to take the entire top off, and it's a whole ordeal, and there's a heat sink that you have to connect to the FETs on the bottom, and it's just a lot harder.
We're all about self-serviceability. Like being able to service a product is really important.
Yeah, it makes a big difference if you've got a system in the middle of nowhere, and you know, shipping a battery is going to take a long time, whereas you can have some of these on the shelf to swap out, or if we do need to send one to you, you can probably get it to you a lot quicker. And it's just going to make the entire process a bit easier. If we move on to the list of approved batteries. So from the range of batteries from Discover at the moment, only the Rackmount is CEC approved at the moment. I haven't checked it this morning, but I've been checking every day. The Helios is awaiting approval from the CEC. We're hoping it's going to come any day. But like I said before, they're pretty swamped at the CEC at the moment. So we're not quite sure when it's going to come along.
They do tell us that we're at the top of the list. So
Yeah,
we're hoping literally any day now that we'll have the Helios on the list as well.
I think they say that everybody knows.
But they may.
So here's the Helios. So for those of you who don't know, it's IP65 rated. As I said just before, 16 kilowatt hours. Again, it's a 16 cell 48 volt battery. It has USB diagnostics. It has built-in heating. The rack mount is available with a heated module as well, but we mainly import the one that's not heated. But it has built-in heating, and it also has built-in fire suppression as well. So it's a really great, compact, easy to install unit, and we're getting a lot of great feedback from people on it. Again, like the rack mount batteries, you can use it in open or closed loop, and we'll go through some of the benefits of that in a moment. But as far as the rebate's concerned, Right now, it's not eligible, but we're hoping, very soon. Yeah, and this is explaining the situation with the CEC.
Almost there. Actually, if you go back just quickly,
That one?
Gareth, either one, just the, I just see the question in the chat there. Does the Helios use the same BMS as the Rackmount? And the answer is yes. It is actually a fourth generation BMS, although the configuration of the board is laid out a little bit different.
It uses the same fundamental board, except for the contactors on the Helios are rated for 400 amps rather than 200 amps. So it's just the same functional BMS, just much beefier.
Yep.
The other difference is that the Helios only has a single pole breaker. So when you install it, you need to use an additional external 2-pole breaker.
That's right.
Which actually with the Rackmount, most of the time you're going to have in a cabinet and you're going to be running to a 2-pole breaker anyway. And if the batteries are within 2 meters of the inverter, you can use the one 2-pole breaker for the battery and the inverter as well. So it's only if it's greater than 2 meters, you would need to have 2 of them serving the same function. We move on to the 210, and we'll have a segment a bit later, James, go into lots of detail, but can you give us just a quick rundown on the 210 HV?
Yeah, the 210 is 665 volt nominal, like cabinet style battery with integrated heating and cooling with the thermal management system. So it's a liquid cooled battery cabinet. It's really designed to connect to, in this particular form factor, connect really easily to hybrid CNI inverters. So Solus is pretty common, or Doya is pretty common. CNI inverters, effectively, you can connect them right up to this in that 665 volt range. With the 210, we've basically got comms ready to go out of this. So from a commissioning standpoint, you can just plug the cabinet and inverter in together, hook up the DC conductors, and you've got small CNI, we call it light CNI solution, kind of out of the box, ready to go. And it's pre-assembled drop-in-place platform that's self-maintained. This is a utility cabinet solution that's being brought into the smaller CNI market space. So it's already, utility markets held to a much higher standard as far as performance is concerned. And so it's already kind of gone through all of that and been vetted. It's got fire suppression, multi-level fire suppression, so pack level, cabinet level fire suppression, fire detection, triggers for fire systems. It's got a high level of disconnection in it. It's multi-fused throughout the system for distribution, big disconnects. This cabinet solution in other formats goes from 600 volts, as you see it here, all the way up to 1300 volts for large PCS in that utility market. So it's really, really good.
I'll add one other thing, just because you don't have it on a bullet point there, is it is thermally managed with the liquid cooling and heating system in there as well. So it's designed to keep temperatures at optimal temperature, whether it's hot or cold. Obviously, it's mainly hot here, but
yeah, it's mainly hot.
It'll keep the batteries at sort of its optimal operating
and
temperature.
It's designed for systems with big M's, not little M's.
Yeah.
But we've got some more slides. We'll go into a bit more detail a little bit later. But am I right that the Helios is essentially a scaled down version of this?
Yeah,
right?
it effectively uses the same cells. So we'll pull the common cells that are used in the utility form factor into the Helios in a 16 cell format. The 210 is made up of 4 53 kilowatt hour packs that have 52 cells each. So there's a lot of capacity in the 210, but functionally the Helios is like the baby brother.
Yeah. I guess that's where it got the fire suppression and all that sort of stuff.
And also like the rest of the international direction. So international standards are pushing batteries in a particular direction. The 210 in the utility market space is held. I can throw a bunch of acronyms, a bunch of words at it that don't really matter too much. Like it's got deflagration, ventilation. Look that one up. It's the Helios is modeled for as an international product, just like the cabinet solutions.
And for those of you who don't know, I can't say it in what it is in the webinar, but the price on the Helios is very competitive. I think the rebate pretty much covers it as well, and that's because it uses these CNI cells.
It's considerably cheaper to manufacture the Helios because of the cells we're using. With that being said, like we can manufacture commercial solutions and the Helios as a small, like a large residential, small, no, they're prismatic cells. Larger residential, small commercial solution, with because of those cells, it is a cost-effective solution without compromise. He's got one of the beefiest BMS you'll find in the industry. We're pretty confident in that. It's all the frills. It's got the fire suppression. You've got integrated heating. We've got contactor style BMS for high current delivery. You've got the busing. I don't know how much detail you're going to go into with the Helios, or if that was it, but it's got like integrated 400 amp busing in it. It's outdoor rated enclosure, wall mounted. You can mount it on its back, like every single thing you could possibly do, and no compromise. It's just cost effective because we're utilizing a utility mass market cell solution for that product.
Yeah.
So just I'm seeing the questions pop up here. So I know, James, you said it really quickly, but the Helios uses prismatic cells, not cylindrical. So
almost everything in the industry is
the Rackmount's prismatic. The Helios is prismatic. The 210 is prismatic. Question there I see as well is will it be upgraded to a two-pole breaker on the Helios? And the answer at this stage is no. There's a methodology for, and I think we understand what that is. You'll have to do an external two-pole breaker. I think the good news is that the price of the Helios is so good with the rebates that the additional cost of the two-pole breaker will, to some degree, almost be a non-issue. And I see the last question is max current on the Helios bus bar is actually 400 amp. The battery is outputting 200, so you can actually parallel batteries together using that bus bar.
On the internal bus bar?
Correct.
Yes. But is the circuit breaker on which side of the bus bar? Because it's got a 200 amp single pole circuit breaker.
Between the cells and the bus bar.
Yeah, okay. Yeah. So you can utilize that. It's a bit of gray area with the standards as whether you can utilize that bus bar. So we haven't been pushing that quite so much.
Right.
People who've been buying it have been using a separate two-pole breaker, then go into a bus bar. But it depends on whether how you read the standard as to whether two Helios next to each other are one battery system or two battery systems. And we've been erring on the side of caution, saying that they're two.
Yeah, it's I guess just depending on how you look at it.
If your inspector's open to it, then
well, if it's of any help, in the U.S., 9540 is the U.S. standard for North America. Is UL 9540 is the de facto highest standard that you can reach. So we're in the process of going through that certification right now. And the way that we're certifying is to what's called UL 9540 DCESS.
Okay.
And they'll be put in and certified as 3 battery systems. So 3 Helios being parallel together utilizing cables.
Yeah, and they look at that as a system.
That's one system.
That's one system.
Yeah, and then anything from 3 down. So you could go,
go 3, 2, or 1.
Anything more than 3, it becomes a conglomerate. So you take it to a bus at that point.
It's an interesting point because for a couple of reasons. I mean, one is that, if you had 2 sets of rack mounts next to each other, say you had 2 of the slimline enclosures, 6 batteries in each. Mm-hmm. I don't think any inspector would complain if you ran them to one bus bar and then had a 2-pole breaker.
That's correct. Yeah.
But the other thing that's interesting about it is in terms of the rebate, and I know it's not approved the rebate yet, but let's pretend that it is.
Hopefully in a couple of days.
With a system like SIG Energy, it's the entire system is what is approved.
Yeah.
And so they have one approval for 5 batteries, one for 7, and so on and so forth. If you add another battery, that extra module by itself is not approved. So it's a bit of a question as to whether you would get the rebate for upgrading the system, whereas each of these Helios batteries are distinctly listed. This is only one of them.
Yep.
And so if you added another one, you presumably would get the rebate.
Yeah.
And it's perfect for 3 Helios's 48 kilowatt hour. So it meets perfectly with the battery rebates.
That's right. Yeah.
So-
Yeah. It's it's just free storage. you know.
Exactly.
That's
Exactly.
It's a great thing. But let's move on because we're halfway through already. So the link to communication gateway, we went over this very quickly before, but we'll get into a little bit more detail about the advantage of using that with these. But the advantages of using the Rackmount batteries for the rebate, I think it comes down to 3 main things, really. A big part of it is the access to myLynk Cloud, which is the online portal. The fact that you can use these batteries open and closed loop, and then the advanced comms and the dynamic charging. So just to dive into this, when we say closed loop, what we mean is that the inverter is getting charge and discharge values from the battery system in order to charge that optimally. And the practical implication of this is, number one, if you've got an inverter portal, you can usually see all that information from the battery. You get the state of charge from the batteries. Now, I used to think that there was some magic thing within the batteries, and maybe James is going to prove me wrong here. But actually, it just does the same thing that something like a smart shunt does. It's
It's coolant counting.
it's just counting the current in and out,
Yeah, nothing novel there.
and the voltage, which allows it
Recalibration of coolant
yeah.
counting.
That's right. So the inverters should be pretty good at this too. But if you've got anything that's DC coupled, then it's not going to count that. So it's best to get it from the battery in most scenarios. But the big advantage of it being closed loop is that the inverter is going to get error messages from the battery, which it's not going to get in open loop. But it's able to have a dynamic charging range. So what that means is that the batteries at their different states of charge, you can get more or less charge in and out of them. But if you don't have comms, you're just going to have to set a value that works for the entire range. But as soon as you have comms, you can go, okay, well, in the middle of the range, I'm just going to, I can pump it in or pull out as much as I like. But towards the top and towards the bottom, when you've got to be a bit more careful, we can dial that back. And so that means that you can actually charge the battery at a higher rate because that maximum value can be higher. Does that fit?
Yeah, I'll say that closed loop or managed, you guys say sometimes as well, that adds a whole level of safety. That goes without being said.
Yeah.
So effectively we're able to dictate how we want to be charged from current to voltage, and keep the delivered power within a range that's safe. So from a power standpoint, we can do that. And then, the most important thing is from a longevity, a life standpoint with respect to the batteries, the longevity of the system's functionality. We're able to guarantee with our closed loop that the batteries are able to receive the full charge and to balance out. And cell balancing is really the most important thing in a lithium battery over the 10 years of life plus that you expect to get from one of these systems. If you really can't guarantee a full charge regularly, you're going to destroy the battery.
And does that mean that you're able to slow down the final stage of charging if you need to bounce? Because
there's a couple different ways we can do this depending on the execution, but we have dynamic CV, dynamic constant voltage, and we have dynamic constant current. And so we can either dial in the voltage. So you can push current by, increasing your delta V, your change in voltage. So you can increase current by having a higher, telling the inverter to have a higher voltage than your batteries are at. So it's going to, push power. Or you can increase current by telling the inverter you want more current. So we can manipulate both values.
Yeah. So that's just Ohm's law, right?
Yes, exactly.
If you want you've got a fixed resistor, V equals IR. So if you've got a fixed amount of resistance, if you want to put more current through it, you're going to have to increase V. in order to increase I. Does that also mean that as the battery ages and the state of health goes down, that the charging algorithm is going to respond to that?
Yeah, the key to closed loop is that we're able to look at the cell voltages of each individual battery within an entire system. So if you've got multiple packs, you've got multiple cells in each pack, we're able to look at the cell value. And when we do dynamic voltage, if any of the cells are diverting, then we can start to pull the voltage down, which allows us to reduce the current because of Ohm's law, and allows us to make sure that we can top balance effectively at a relatively high current. So it can allow us to be able to manipulate the system quite well, and to not only balance cells but to balance packs.
Yeah.
It becomes a lot less necessary when you have like Helios because it's so much more energy dense. But this was all originally derived for like Rackmount concept as well. So
I guess they're less complex, the Helios, because they're typically fewer cells, right?
exactly. Well, it's 16 cells, fewer cells in a larger system. But, and the principles have proven themselves over a decade worth of R&D.
Yeah.
And so.
Well, when you think about our old battery, the 6650.
Yeah.
How many cylindrical cells were inside? It was
right.
really important to keep that many cells balanced.
It's just double A's, really.
Exactly. It's like a large battery.
C's,
Yeah.
And after saying how great closed loop is, we're now going to talk about how good open loop.
Yeah.
So you can use these batteries open loop as well. So there's some batteries out there that only do closed loop, and there's some that only do open loop, but you can use this in both scenarios. And it means that if the battery loses comms, it won't necessarily shut down. Some inverters, so Cellectronic, for instance, if you lose comms, then it will shut down until you turn it back on again without the comms there. But that's just a function of you just pull the canvas cable out and turn it back on again, and it boots up like it never had it. Whereas NOARC, if you have BMS error stop on, you'll need to reprogram it to go to open loop. Because generally, I think it's a good thing that it stops if it loses comms, depending on the scenario. But if you're in some, what are some scenarios where you think open loop would be more appropriate?
I'll be honest, I don't think open loop's the most appropriate thing. If you can do closed loop, the only time open loop is really appropriate is if you have legacy hardware. And you really need to support that. I think the closed loop side of things has been quite dialed in at this point.
Yeah.
I mean, we've been doing closed loop, I would dare I say, almost longer than anybody else, with the exception of a company that starts with a P. And I think that most modern inverters these days really support closed loop fairly well.
Yeah.
And a lot of problems can be solved with firmware.
Yeah.
So, but if you are having an issue with a particular inverter, not doing what you expect it to do, then pull the comms and set the values conservatively. The only thing with open loop is that if you look through our integration guides with an open loop configuration, is the values tend to be much more conservative than you would see in a closed loop because we're not able to manipulate those values. So if you are doing closed loop, it could potentially take longer to charge because the values are more conservative.
Yeah.
And then the other thing with closed loop is it's important to make sure that the inverter's voltage, what the inverter thinks it sees and what the battery actually sees is the same thing.
Yeah.
Because a lot of these inverters just have really poor QA, and they don't necessarily dial their voltages in perfectly.
Yeah. Yeah.
And so there could be 1,000 millivolt difference between what the inverter perceives and what the battery actually is. By the time you get from the inverter itself, through the cables, through the BMS, through into the cells, like there's a big difference, or sometimes even the logic just is so far off. You just have to make sure that you dial them in and adjust the voltages so that you.
That's where I'll just say maybe to answer the open loop question first. Our limit is 36 batteries for a closed loop or a managed system. So if you're going to go to 40 or 50 batteries, you may have to operate in an open loop because you can't physically connect 40 batteries in a closed loop scenario.
Also, with that being said, though, it's sometimes better to do 36 batteries in closed loop and leave the rest of them open because it's an aggregate value at the end of the day. We're controlling the inverter based on an aggregate. So an aggregate of 36 and an aggregate of 40, it's almost the same number at the end of the day. It's averaged across 36 batteries or over 40.
It's got a question here. How many Helios ship per pallet? It's one. It comes on a skid itself. So, well, we have pallets out in the warehouse actually, which have eight.
Yeah.
But then each one is on its own little skid. And they're actually quite easy to manipulate. They weigh like 150 kilos and I weigh less than half of that, but I can push it across the floor on the pallet actually surprisingly easily. And I do know people who installed them by themselves, but usually it's going to be a two-man job.
Yep.
But let's move on from open loop. I guess we could summarize that by saying, unless you really hate doing comms or you're doing some sort of system that doesn't have comms, then closed loop is the way to go. But there's nothing.
Chances are you hate doing comms because you've had a bad experience with comms.
I think that's
really what it boils down to. And so, I mean, with the Lynk or with the Helios being natively plugged in, it's a lot easier. The Lynk makes it easy because you can adjust the pin out.
Yeah.
But it's been a pain traditionally or unreliable, and I think companies like us are working to make it more reliable and less complex. So.
But I think it's important to point out that there's nothing inherent about the Discover batteries that mean that open loop is inferior compared to other battery companies
certainly
that
not
don't provide.
It's certainly not a requirement.
So there's companies out there that don't provide comms at all. There's nothing that they do that these batteries don't do that allows them to do that. It's the same as on that platform. But let's move along. So this is just more details about closed loop charging. I think we've covered that.
Yeah.
And then the advanced comms is a major feature. So the ability to see what's happening at each individual battery is a really big advantage for the Discover system. So a lot of batteries out there, battery manufacturers out there, you only see the CAN bus going into the inverter, and that just gives you the aggregate of the system. Whereas with this, when you use the Link 2 device, when you either plug in with a laptop on site or you use the portal, you can see the state of charge and the state of health and the voltage and the current for each individual battery. So you can see there's a demonstration here, and you can see we've got 4 batteries across, and then we've got the capacity, the voltage, the current of each one of them. And what you'll see is, say you're doing an installation, you've got a bunch of batteries. When you don't have that overview, you put them in and you don't really know what's happening, but they'll all come to the same voltage pretty quickly. But what you don't see unless you have an overview like this is that actually the state of charge is miles off, and they'll go up and down, and it will take a couple of turns for them to actually all synchronize to the same state of charge. And with most other manufacturers, you just don't see that. And so you can't really tell if one of them is kind of dragging but the other one's behind, or if one of them's taking more current of the others. You wouldn't see that on a day when you're commissioning the system. You're going to see it later on. And I've got a slide that explains that a little bit better. I think it's a bit further along. The ways of interacting with this information is two ways. Is with the laptop on site, which has been the case for quite some time, and there you can see each individual battery. You can change the specifications and the settings of the Link 2 device itself, and you can update firmware, and you can download really detailed data logs from each individual battery. And these data files are huge. Once the battery's been running for a while, you'll click download, and then you come back 20 minutes later or something to download them. It takes a reading every
5 seconds.
It's ridiculous. But when you're troubleshooting, it's really useful. And then on the Link Cloud, it's pretty much the same, but you can't download those massive files because it's just the bandwidth would be too much. Is there plans to do that in the future, or?
There are plans to include a download of data files later. It's just really becomes a bandwidth issue.
Yeah.
And through the cloud and the data that you see, it's actually being logged every 5 minutes. So it's not every 5 seconds. So it's not quite the granularity you're going to get by downloading the native files right from the battery itself. But there are plans in the future roadmap to do that.
The benefit of Link Cloud is the push notification capabilities of alerts. So, like the data that you can see can show you some anomaly associated with, some discharge charge characteristic that might, cause an issue. But that anomaly often presents itself as an alarm or something as well.
Yeah. So we can see here, there's an example of what James is talking about. This is the alarm page. And so you've got a bunch of variables there, voltage, current, temperature, those sorts of things. You can turn the alarms on and off. You can set your thresholds. And then you can also decide who's going to get the alarms as well. And I've used these to good effect. And you also have this overview that you have that I showed you before. This is all available on the cloud. And just to illustrate this point a little bit more about being able to see what's happening with the batteries, if you don't have an overview of each battery in the system, you don't really know what's going on when you install it. And they're going to be all over the place like this when you first install them, but they're going to equalize eventually. But if you have one that's not doing it, you're going to be able to see that on Link Cloud, and you're going to be able to see it before it actually goes into an error state. You're going to be able to see that. You can see the writing's a bit small here, but you can see the counted energy in and out of each battery, so you can see if one of them is just working way harder because its values can be much higher. And so that allows you to see this information before it goes into an error state. And so if you can see that before the customer sees it, before the system actually has a problem, that's a huge advantage to you. Number one is that you're not going to lose as much face with your customer if you say, oh, look, there's an issue, rather than them calling you and telling you there's an issue. But also just in terms of the amount of time that you're going to spend on it. So it looks like my new webinar platform doesn't use slides properly, but this is basically an explanation for how much time it's going to take you. If you don't have remote monitoring, you've got to go to site, inspect the system, remove the battery perhaps, come home, do your warranty process, go back to site, swap the battery, come home again. Let's say that's 8.5 hours. Whereas if you know what the problem is beforehand, you can do all your warranty process and your analysis before you leave. And then it's one trip to site, change the battery out, come home again. It's half the time, because you don't have to go there and figure it all out. You can do it all remotely. You can email Discover or us if you've got a question about it. And you don't have to spend that valuable time on site. And because you saw the problem, before it happened, you can choose when you're going to go. It's not going to be an emergency that's going to slow down another job or something like that. That's if you cost out your time out per hour, that's a huge saving there alone.
I would say, Gareth, that's assuming that there's actually a fault in the battery and that there's actually a warranty. There's plenty of cases where we've seen installers being able to diagnose a problem that is actually not a warranty, that they could have the homeowner actually interact with the battery because they know exactly what's happening, and be able to instruct the homeowner to go and hit a power button, just turn the battery back on again without having to roll a truck out and do a service call. Yeah. So it becomes an incredibly powerful tool for an installer. We often say it's know before you go, or know and not have to go even.
K.
Oh, no, right.
No, K-N-O, not no, N-O, But it does make an installer's life an awful lot easier in being able to understand what's happening with the battery before you actually roll a service vehicle or a service call out to a customer's site.
Yeah, I mean, it's like the Victron online monitoring platform is just so much further above all the other ones. It's so much easier to diagnose that stuff, in my experience. You can do it all remotely.
Yeah.
Whereas other ones, you just have to go there.
Yeah.
And it's just so much harder.
The biggest benefit to me is it's actually a free service that we offer. It's not something that an installer has to pay, a monthly fee to manage all the systems that they have. It's actually included when you buy a Lynk device. It's part of the cost. You create a free account online and plug it in, and off you go.
The Lynk device also has relays built into it, which can be quite useful. It's got a really good generator stop-start algorithm, which is comparable to the Victron one. Victron one's probably got slightly more features, but it's the Discover one's pretty good.
That was developed for applications in OpenLoop.
Right. Yeah.
Right, where your inverter cannot track the SOC accurately.
Yeah.
Because of legacy Coulomb counting algorithms.
Yeah.
And so you can utilize actual state of charge to do gen start stop function.
Yeah.
That's what it was developed for.
Well, I think it's good for so the Victron one is powered by the servo, which most of you will know is powered off the DC bus. But with other inverters, which are just AC inverters, and it's all in one, I think it's a bit more problematic to have the generator being started by the inverter, because if something happens to that, the generator is not going to get started.
Yep.
Whereas if you can start it from the Lynk 2, then at least maybe the house is going to continue to run and pass through or something like that.
Yep.
Maybe the batteries will still charge if it's not inverting. And it's got another 2 relays you can use for other things as well. So you could use those if you're using it with Selectronic and you wanted to have DC coupled charging as well. There's a few mechanisms for doing this, but you could use the built-in relay on the Discover to either tell the Selectronic to dial back its charge rate based on the state of charge of the MPPT, or you can just, using the Victron remote, you can just turn the MPPT off at a certain state of charge. There's a bunch of things you could do with it.
Load shedding is a huge one.
Yeah, load shedding.
You set it on SOC, so if you reach down to a 30% SOC, you could drop off an EV charger perhaps, or you might drop off a water tank or something like that. It could also be conversely used for a load dump.
Yeah.
So if you're in overproduction and you have nowhere to put your power, you could have it load dump into another device of some sort. So
pump water, heat water.
Pump water, heat water, the two most common.
You can use it for alarms as well. So there's high temperature or low temperature. You can use it to control external heating. You can use it to turn on a fan to cool like a cabinet, or turn on an air conditioning system if it's in a remote area, for example. There's at least 10 different options that you can use. Exploring it.
Yeah.
It could be a whole webinar in itself.
Yeah.
With that.
I've even heard of people using it to turn on the lights, green for full, red for empty.
Yep.
But we're going to run out of time.
So let's keep going.
Let's keep going. We're nearly near the end. This is all just 210 stuff. So I'll just dive into that. Here's some nice pictures of it. So it comes with 4 batteries. There is another product which has more batteries in it, right?
Well, so the cabinet product line as a whole is, what you see here. The 210 is this variant with 4 packs, but the 210 is specifically just set up to just plug right into a hybrid C9 grid, like Solus or whatever preference you have. It's out of the box. It's just ready to work with that. Then our larger cabinet lines will have potentially more packs, all the way up to 8. So unit of scale with a 210 is 200 kilowatt hours. 4 packs, each of those packs is 53 kilowatt hours. And then up in the top left-hand corner of that, you can see the thermal management system. So that's what circulates the glycol around the cabinet. In the bottom left-hand corner is where all the DC distribution comes in. And the AC connection to power the thermal management system and the UPS system. And then at the top, you'll see a bunch of fire detection such. The cabinet's broken up into 2 sections. So you have the power side, which is on the right, and then the connections and thermal management system on the left.
And one of the things about having the 4 is that that's sort of a sensible weight, right, to be able to fork it in and out.
Sure. That's one reason. We do this in all different variations for different types of products and different types of applications. When we get into the more larger scale utility scale solutions, you can put 10, 20 of these cabinets in a system, a 5 megawatt hours or more for those projects. In a smaller single unit scale, 200 kilowatt hours is a good unit of scale, and also it pairs up really well with these common inverters that are available on the market.
Solus 50.
Yeah, the Solus 50 is a really common inverter. You can just plug it right into our comms and hook the DC up, and then you're off and going. I mean, it's plug and play, dare I say. The commissioning for a CNI, a larger scale CNI solution, could be weeks, potentially, depending on how complex it is. The commissioning for like a 210 and a Solus is like minutes.
And so these are going to be also the type of applications for these. So we quoted on one recently for like a pumping scenario, a large scale pumping scenario. But what other type of applications? So it can be like, what do you call it? Grid stabilization, that sort of stuff?
So you can use it for peak shaving, time of use, if that's applicable here. From in a grid interactive style application, any economic driven energy storage solution. So that'd be peak shaving, time of use, or a value stack thereof. Self-consumption, where you're utilizing your solar to minimize your consumption. What?
Remote or off-grid?
Yeah, so then we can segment it off into completely off-grid or resiliency-driven value stack, right? So like if you're just using it for economics, and we do a lot of that, then it's great for that scenario. Then you can add the resiliency there because especially it's like a Solus already has a built-in disconnection for the grid. So you can take the whole, your backup panel completely off-grid if the grid fails. So you can add that resiliency. And then if you just, have an application that's completely off-grid, then you can do completely off-grid as well and couple that with a generator. So it fits all these different segments. I mean, it's a Helios on steroids is what it really is.
Yeah.
It's just a bigger battery for larger applications. One of the benefits of using a Solus, for example, is you can parallel on the AC side of the Solus multiple inverters together to grow the system. So you can have 150 kilowatt Solus, so you could have, 5 of them for 250 kilowatts. And you can, with the 210, you can put one cabinet on a Solus, or you can put 2 cabinets on a Solus. So you can have 200 kilowatt hours or 400 kilowatt hours on 150 kilowatt inverter, and then you could grow the system proportionally to meet whatever size you need in that sub 300 kilowatt range. And here's a good example of that. This is a off-grid grocery store, basically, use case. They dropped these on. This is a retrofit, actually. So they came in through the side of the cabinet, and they're feeding effectively the equivalent of a 50 kilowatt Solus inverter. This was in Pennsylvania in the States. And so over there, they have a brand called Solarc, which is effectively a Doya, D-E-Y-E. You guys carry those as well, right?
Yeah, we call it Day. I think everybody pronounces it differently.
Everybody pronounces it different.
Yeah.
Sure. Doya inverter over there is branded under the Solarc brand, and it's a pretty common package there, just like you would patch it up with Solus. And
the height of the cabinet?
We call it an eagle feathers, being a Canadian.
Right.
It's 8 feet tall.
8 feet.
And it's about 4 feet by 4 feet.
Yeah.
And
So
what's
about
that in
2
what's that in English?
2.2 meters.
2.2.
Yeah. Okay. Yeah.
2.2 by 1.6, I believe.
Yeah.
Yeah.
So the nice thing too, when you install these, and you can't see that in this example because they actually brought all the DC, AC, and the comms connections through the side of the cabinet.
Yeah. Okay.
But if you were to have some foresight or had the ability to pre-pour your concrete pad and run conduit up, you can actually install coming up through the bottom.
Yeah.
And then there's zero space requirement between the cabinets. So you can actually sandwich them together to minimize the amount of overall space that you require.
That's a bigger issue in the States, I think, that the space between cabinets.
You don't need to in the States with this cabinet at
With
all.
this one, that's good to know. Yeah.
It's pat. So again, in America, we go through the same UL listings for 9540. Well, the prerequisite to 9540 is the UL 9540A test, which is where they're testing propagation for thermal runaway between cells. And then what happens outside of that, and does it spread to other cabinets? So of course
Yeah,
we've
okay.
passed that in such a way that you don't actually need to leave space between the two. You can actually
Yeah, we
separate
don't
them
even get
together.
propagation through the module.
No, I think it's going to cut us off. We just reached 1 hour. I haven't used this platform before to see what it's going to do, but we should wrap it up.
Yep.
So the 210 is not available for the rebate because it's over 100 kilowatt hours.
That's right.
You can't even claim like the 50 kilowatt hour segment of it because it's over the 100 kilowatt hours, unfortunately. But I think the type of applications you'll be using this in can be different anyway. If anybody's got any other questions, please quickly put them in the chat. Otherwise, we will finish up there. We've got all your email addresses, so we'll be sending out the slides and information on all these products. If you've got any further questions, you can email me as well. And we'll be doing more of these in the future. Let us know what you would like to see, but we'll be doing some more on some other products as soon as possible. Thanks everybody for coming. Thanks James and Matt.
Thank you.
Thanks for having us.
coming
I'm sorry for being late.
Oh, good. Let's see how we do this.